Are you able to hear me?
Yes, sir.
Okay. I'm getting some echo. Just give me a moment. Okay. So now are you able to hear me?
Yes, sir.
Okay. Okay. Fine. So yesterday we have discussed about cloud functions, right? So we have seen a simple cloud function, and we experienced with GCS based event trigger for cloud function, and we have clearly observed the features of cloud function and where we use the cloud function, right? So all these things we have seen yesterday, right? So today I'm going to introduce a new service to you, right? Which is actually Google Cloud PubSub. Okay, so this is a new service altogether. Okay, and this service is especially meant for streaming applications. Be very clear. Okay, so now if you see cloud function or if you take workflow, right? So the major triggers or the major triggers for your cloud function or workflow are two. One is a GCS based event trigger, another one is a PubSub based event trigger. Okay, so this PubSub is very important for data engineers, I can say, because most of the data engineers in the market they are, I mean, we see very small people, small number of people who knows streaming, okay, who knows streaming applications. So what do I mean by streaming and what is this PubSub? We will see slowly. But before that, we need to understand our real world applications. Okay. So I'll tell you one example. Let us take an example. You have a phone pay or Google Pay application or app in your mobile, right? So when you do a transaction, or else you take Flipkart, it is very good example, right? So when you select your order, when you went to payment option, your payment will be routed to your bank website. Are you with me or not? Flipkart is one web application, and your bank have a different secured application services. So now your Flipkart application needs to communicate with your bank application, right? So there should be a communication bridge that needs to be established between the applications. If there is such kind of a need, then we will be using a service called message queue, which is actually a streaming service. Okay, so now what Flipkart application will do, Flipkart application will send a message to your HDFC or your ICICI bank application. Okay, now that application will receive that message, and then it will react according to that message. This is a streaming real time. There is no delay, right? So in real time, if two applications want to talk to each other or communicate with each other, then you need a communication bridge, right? So that bridge itself is a message queue service. We call it as message queue service. Okay, so now let us quickly share my screen. I'll try to put that in a, okay, so let me quickly show you how it looks like. Let us take an example. Okay, so let us take an example. This is something that we will take as a topic. Okay, or a queue, message queue, you can say it is a message queue. Okay, now this side you have app tier 1, or else we can call it as app tier, or as application 1, simple, for simple understanding. And for this side you have application 2. Okay, now this altogether a different applications, right? Your bank is a different application, your Flipkart is a different application. Flipkart is a e-commerce web application, and your bank is a banking application. So there should be a connection, or there should be a communication mechanism that needs to be established between two applications, right? So that is where there is a concept called message queue. Okay, message queue services. So this message queue service, meaning MQ, we call it as, in a legacy system we call them as MQ systems. Okay, so these MQ systems are of two types. Okay, these MQ systems are of two types. One is point to point. Okay, point to point message queue services. Okay, publish subscribe message queue services. Okay, so these are two types: publish, subscribe. Okay, now in point to point message queue systems, right? In point to point message queue systems, you will be having one sender and one receiver. Be very, very clear. We'll be having one sender and one receiver. So you have one sender. That means who are sending the messages, or we can call them in our cloud systems, or in a advanced streaming systems, we call them as producers. Okay, who will produce the messages. Okay, senders or producers. So here you can in point to point messaging system, you can have only one. This is point to point. Okay, so in this system you can have only one sender and one receiver. Be very, very clear. Okay, so one sender and one receiver, and they will be sending messages. Sender or producer will be sending messages, and the receiver or consumer, we call it as receiver or consumer. Okay, so this is a consuming application. Okay, so now you have sender, you have one sender and one receiver, and sender will push the message to this message queue system. So here message 1 came, and this message will be consumed by your receivers. Okay, now as and when your receiver consumes your message, your M1 from the queue system will be removed, and there won't be other consumers or other receivers for this same message queue. So this message queue, we call it as a topic. Okay, topic is a place where actually producer will push all the messages. Okay, this is a medium between your producer and consumer. Okay, so now what will happen, your producer will push the message to the topic. Okay, your topic holds the message, and your receiver immediately picks that message and process it, and then respond again back. Okay, so it's actually the communicating channel. Okay, this is actually the communicating channel. Now what is happening in older message queue systems? So you have only one sender and one receiver and one message queue. Okay, because of this reason, there won't be much uh, more communication established between the producer and consumers, and there are a lot of problems because of this message deletion, right? So as and when your consumer receives the message from the topic, that message will be removed from the topic. So this is a very big problem, right? So that is where the distributed pub sub, publish to subscribe models came into the picture. So this is a older one. Okay, so Now we have the most advanced PubSub models are there for streaming, right? So you can have many producers. Okay, you can have many producers, or else you can have only one producer and multiple consumers. That is PubSub, publish subscriber. We call it as publish subscriber model. Okay, so you can have multiple consumers for same topic. Be very very clear. Okay, now you have one topic, your publisher will be pushing messages continuously to the topic, and you will be having multiple receivers who will subscribe to the topic, right? So we'll do registrations first, otherwise our applications won't be able to recognize us, correct? So the registration is something we call it as a subscription here. Okay, you what whoever the consumer is, if they want to consume the data from a particular topic, that consumer needs to be subscribed for a subscription. Okay, so we'll create a subscription, and that subscription needs to be subscribed by all the consumers, then only they will be able to access from the topic. So this streaming kind of applications, this PubSub kind of services can be implemented by the technologies called Kafka. So in our on-premise solutions, okay, in our on-premise solutions, for example, legacy systems like Hadoop, when Hadoop was there, so Kafka is a distributed message queue service that we have. That is the most advanced message queue service that we have. Okay, and in the cloud, we have different pub sub services. Okay, so in if it is on-prem, the most advanced streaming service is Kafka. It's a pub sub model, and it's distributed, and it's a cluster based service. Okay, now in the similar fashion in the cloud, we have different services. Like in Azure we have Event Hub. Okay, in GCP we have PubSub, Google Cloud PubSub, and in AWS we have Kinesis. So Kinesis is another streaming service by AWS, right? So in each and every cloud systems, they adopted this PubSub model, and then they have implemented their own service. Okay, now, okay, Venkat, you are telling, okay, so this is a streaming service and everything is good. Where we will use this streaming in GCP? Okay, where we will use this streaming in GCP? So if you want to build real time data streaming applications, remember, okay, if you want to build real time data streaming applications, let us take an example. You have a producer, and which is continuously pushing data to your topic, and you need to process the data on the fly continuously, message by message you need to process and store it in the target system. So you need to write a producer and you need to write a consumer. Okay, now I will give you a simple use case where this streaming can be implemented. Okay, so let me quickly. Okay, now we have the real time use case I'm telling you guys. So let us take an example. You have Oracle database. Okay, and in here you have 10 terabyte data. Okay, now on top of this Oracle database, you have a web application that is running. Okay, so your web application is running, or else an analytics application or something, some kind of, let us take an example, a search application. Okay, search application. Now this search application is running on top of your Oracle database, and this database is holding 10 terabyte and it is keep on growing. Okay, now on top of this 10 terabyte data, there is a search application. Similarly, there is a reporting application. Okay, similarly, there are some dashboarding that has been done. Okay, some other. For example, some other teams, let us say other applications. Okay. So now what is happening? So here, if you see, there is an application called a search application which is running on this Oracle database, and this search application is running dead slow because of huge volumes of data. Because of huge volumes of data. Now the business, this search application is very critical for the business, and this application is running dead slow because the backend database Oracle is holding very huge data, and it is going to search the data, and it is scanning all the tables, very huge tables. So that is the reason the query itself is very slow. So the search application is very slow. That is the business problem. Okay. Now all the other applications are really fine because they have their own advantages. Like they can serve the business a little bit late also. Let us take an example. I can visualize yesterday's report today. That is fine for me. I don't want today's report in my reporting application. Similarly, few other applications, they are okay with the delay, but this such application is very, very critical to the business, and it needs to be very fast responsive. Okay. Now they came to us, actually. I mean, when I was in Mapper, so that's my previous company. So they came. Amway is the customer. So most of you know Amway, right? So the products, Amway products, we used to know it's the chain market that happened in India, and we banned that product. But in few countries, Amway is a very popular brand. So that client has came to Mapper, and they have explained this problem statement. So now there is no way we can decommission this Oracle database because there are very production critical applications that are running in. They asked us to improvise this such application performance. Okay. Now, so our solution architects given a solution in such a way that we have implemented a CDC feature. Okay, CDC, change data capture. Okay, meaning a real-time streaming application between Oracle to one of the NoSQL databases called MongoDB. This is one of the NoSQL database. And here, what we have done, this CDC we have implemented using Kafka. Okay. So in CDC, what will happen? I'll explain you step by step. Please follow me, guys. So here in Oracle, you have 1 terabyte, a 10 terabyte data. Okay. Now this 10 terabyte data in the initial load, you don't load this 10 terabyte data into MongoDB. Okay. So the first step for you is write a producer and consumer. Okay. Write a producer and consumer. So this producer will read the data from Oracle. So as and when a record got inserted, updated, or deleted, these are the three operations they can perform on this Oracle database, correct? So as and when a record or a transaction happened on on a table, immediately your producer will go and read that transaction. Immediately it will be continuously monitoring Oracle log files. Okay, as and when a record comes in, immediately this producer will pick. Okay, so then immediately what will happen, this producer will push that message to the topic. Okay, on the right hand side there will be a consumer. I mean, we have written this producer and consumer in Java, but we can write this producer and consumer in Python as well. So we have used Kafka as a distributed streaming platform. So the producer is communicating with topic and Oracle. Consumer is communicating with the topic and MongoDB. So as and when a record got pushed into the Oracle, your producer detects that change and it captures it. Okay, that's what CDC, change data capture. So capture that change and push that message to the topic. So your message will come. Okay, so ID1, sorry, ID1. Okay, let me take. Your message will come like this. So ID1 operation insert. Okay, so when the message comes like this, immediately in the consumer, we have written the logic. Okay, if for this table, if the operation is insert, then simply insert that record into the MongoDB. So what will happen? Your ID1 will be inserted. Now you got another record for the same ID1. You got salary 200 into the Oracle. That means, let us take an example. It is an update statement. Okay. Now what will happen? Immediately the consumer will read that message and check the operation. Okay. So if it is update, what your consumer will do? Consumer will go and read this ID. Okay, so if check if this ID is there or not. Okay, if it is there, then immediately it will update. If it is not there, it will insert. So that's the absurd operation that the consumer will do. Based on the operation, the consumer will be developed. So like that, we have 100 different tables in Oracle. Okay, and we modeled them in MongoDB to 5 tables. Okay, so the NoSQL database modeling plays a key role here. So how you define your tables, how you design your row key is a different concept, but you just focus on the streaming thing. So how we implemented, so message by message. So now what they have done, so they just disconnected this Oracle connections, and they just moved this search application to MongoDB, and all the search application filters are row keys in MongoDB. So immediately, once we productionized this, we got around 15 terabyte data, and keep on growing from Oracle, right? So keep on growing, and but still your search application, the search application that we have developed is giving response in milliseconds, right? And this is a real time pipeline, right? This is a real time, as and when the change happening in the source, immediately that is reflecting in the target. Immediate, it is immediate, guys. It is not even a second delay, I can say, but it is immediate. Okay, so that is where your distributed streaming platforms are serving the business with the streaming applications. Okay, so this is the importance of your streaming platform. The consumer, in my case, it is doing upsert operation with MongoDB. In your case, it may do some insert operation to BigQuery. It may do some. It may trigger some data proc job. It may insert a record into your database. Whatever it may be. So the functionality will be depending on your business requirement, but you should know what is a producer, you should know what is a consumer, you should know what is a topic. If someone comes to you and asks, hey, could you please create a topic for me in PubSub? Yeah, I can do. So you should say that. Okay, if someone comes to you and asks, hey, can you enable a PubSub trigger for my cloud function? Yes, I'll be able to do that. So you should know the bare minimum basics of your streaming. Otherwise, it is not complete. Okay, so today we will see how to communicate with this Google PubSub streaming service. Okay, streaming system. Yeah,
Venki,
any
before
question?
that, I'm having a question.
Yes,
So you said we are having 10 terabytes of data in this Oracle DB,
yes,
and the such application is actually interacting with this Oracle DB, right?
yes, correct.
So are you copying the entire data into MongoDB and then you are pointing this search application to MongoDB, or how it is happening?
So first we implemented this CDC pipeline. So it started pushing the messages, the recent changes. Let us say from a particular timestamp, it started ingesting the data, and the pipeline is productionized. The streaming pipeline is productionized. Then we have taken another task to backload the data from that timestamp to prior 5 years or 10 years, whatever the data it is. So the backload job, right? So for this we have used the Spark application to pull
Okay.
this entire data from, from wherever. For example, this CDC application started from T1, right? So let us say T1, we started this production application, and T1 minus 5 years or 10 years, whatever it is. So that is the input for backload job, and we went into Oracle, and using Spark, we applied all the consumer the modeling processing, right? So here we have converted them to 5 tables. All that processing we have applied into Spark, and then we loaded into this MongoDB. So this backload is a one-time job. We have taken this up once this real-time pipeline got productionized.
Okay, once everything is ready, that time only you have pointed the search application to MongoDB, right?
Yes, correct, correct. Once the
Okay.
backload job is completed, then we have migrated this such application
Okay.
APIs
So
or
and one
endpoint.
more question, like
Yeah.
you have backloaded, you have applied the backload job for 5 years or 10 years. So
Yes.
if the customer needs before the data also, in that case, what we do, like do we apply the same kind of messaging queue
Uh,
to get the
uh,
to fetch the details?
no, no. Here there is no messaging queue for backload, right?
Okay.
Messaging queue is only for the streaming. So the changes that are coming on the spot, those will be pushed to message queue. The backload is for the backdated data. For example, from today I productionized my CDC pipeline. So whatever the changes that are coming into Oracle from today, those will be taken care by my CDC application. Okay, the real time CDC application. But data from past 10 years till today, I don't want to use CDC application for it. I will go with my Spark processing, where I can go and connect with Oracle and pull the data from for past 10 years, and then process it and load it in a single shot to MongoDB. Bulk loading, we can say that. So CDC is for real time loading. So as and when the message comes into Oracle, immediately that will be processed and pushed to the MongoDB.
Okay. Thanks.
Yeah. Any other questions, guys? Are we good? I mean, I mean, anybody have any questions on the
Yeah,
streaming application understanding? Yeah.
yeah, I have a question like here only. Once we like the such application is got disconnected from the Oracle, still
Okay.
that CDC process is enabled, like from where the changes it will pick from the Oracle itself, or
Yeah, yeah, from the Oracle itself. See, that's why I have given you three applications.
okay,
So only the problem a business is facing with such application, not with the remaining applications. So remaining applications are still pointing to Oracle. So there is a dependency in Oracle, right?
okay, okay. Some I think from other applications we are still getting the data into Oracle. That data we are
There,
using
there are
in a
there
such
are few
application. Okay,
applications which are pushing data to Oracle,
okay, okay,
and that
okay,
data will be consumed by some other applications which are okay with the delay.
okay, okay.
Yeah.
Thank you.
So here the final point is like we are actually pushing the data with reporting application, other application into Oracle. From
Yes.
there, the data will be moved to MongoDB. That's how it actually works, right?
No, if you want to implement a real-time streaming, that's where you need to think of this CDC mechanism. For example, if it is a batch, let us take an example. I want to run my pipeline every day once, or every 6 hours. I want to go and extract the data and then push it into target. That is one way of doing. Okay, that's we call it as the incremental load. Okay, the streaming is there will be few critical applications which doesn't accept delay. Okay, whatever that is coming to source, immediately that should be reflected in the target. So if you got this kind of requirements, what you need to do, if you go and use Spark, right, what will happen? So you won't be able to match that timelines. So Spark is for batch processing, right? Though it supports real time, it is not complete real time. It will support near real time. But if you want real time functionality, let us say immediately a record got inserted into the Oracle, and in the target dashboard, reporting dashboard, it should be reflected. So how you will implement such kind of faster streaming applications, right? That's where this Kafka will come into the picture. Similarly, in cloud, if you want to implement, Google PubSub will come into the picture. So whatever it is, batch and streaming, these are two ways of loading the data into the target systems. Be very, very clear. If it is a batch, it will run periodically. Your data pipeline will run periodically, meaning for every 4 hours or 6 hours or 12 hours, you will schedule that pipeline, and it will go and pick the data in that time range, and it will push it into target. But if it is a streaming, you don't have that feasibility to, I mean, your user or end customer does not have that feasibility to wait till that 6 hours or 12 hours. They need data immediately. So as and when the data comes into the source, immediately they need data in the target. For this kind of requirements, we'll go with the streaming. In streaming, there will be three concepts. One is producer. You need to write a producer logic. And one is the topic. You need to push the messages to the topic. And one is a consumer. You need to consume that messages and then serve accordingly. So this is a streaming implementation. So you got it, Sai?
Yeah, I got it. One last question.
Hmm.
That so here in this scenario,
Hmm.
the customer actually, the client actually does not need the latest data, right? So in that case, have you guys removed this after the implementation, or
Why?
the
What do you mean by customer doesn't need latest data? He
like
need latest data. He need
latest data?
latest
So
data.
in that case, you actually maintain this pipeline, right? This pops up. You just maintained whenever the record inserted into Oracle, so
Hmm.
immediately it actually inserted into MongoDB also.
True. If the record is update, it happened to past previous 10 years record. What will happen?
So that time also it will get update in MongoDB.
Yes. So it is not only the latest data insert, it is also updates to the past data.
Okay.
Okay. So when it got updated, if the from the front end, if they searched 10 years back ID, so the latest update should reflect right in the MongoDB. So that's how it works.
Okay, got you.
Okay, fine. So now let's see how actually in our GCP how we can communicate with our PubSub, right? So here, if you see, when you go to our GCP platform, so we have a service called PubSub for it. See here, real-time messaging service. So when you go to PubSub, so you can see all the topics, right? All the topics you can see, and subscriptions you can see, and all these things you can see. Okay, but we know what is a topic, we know what is a subscription, right? So if from a topic, if multiple consumers are trying to access the data, then the consumer should subscribe to the topic first, then only that consumer will be able to access the topic messages or the topic data. Okay, so let us quickly see how this streaming works, right? So I am using a simple console. Now I'm just using console producer, console consumer. Okay, I'm not gonna implement any kind of a Python. Okay, so now I'm just using console producer and console consumer. Okay, now let us understand that. So here, if you see, there are few G cloud commands. So if you can see, to create a topic, first step is we need to create a topic, right? So to create a topic, we have a gcloud command, gcloud pubsub topics create. Okay, and then I'm just creating, let us say, I'm just creating a topic called EMP. Okay, so all the employee table data will come into this topic. Okay, assume like that. So now I'm just creating this topic. Okay, see here, this topic got created. Okay, so whatever you are doing with the G Cloud, you can do that with programmatic things also. With Python also you can do that. You can do that. Okay, so I will show that as well. Okay, so no need to worry. So here, if you see, we can list the pub sub topics that we have in the Google Cloud platform for a specific project. You just log into your Vertex AI notebook and execute this pub sub topics list, right? So you can see the list of topics that you have. Where is this? Yeah, here. EMP is one topic that you have, and test is another topic that you have. Okay, so once you created the topic, so what you need to do, so you need to push the message to the topic. Okay, or else you need to let us say I will create the subscription first. Okay, so for my topic, I'm creating a subscription. So this is the G Cloud command to create the subscription. So the first and foremost thing is the topic creation, and then the second is the subscription creation. So you need to create the subscription so that your consumers will connect to your topic through that subscription. Okay, so now I'm just creating subscribe EMP. Okay, subscribe EMP, or else EMP subscription, I can say EMP subscription. So topic equals to EMP. So for this topic, I'm creating a subscription called EMP subscription. Okay, so as and when you created the subscription, I'm just starting my consumer in the other window. So how you will consume the messages, I mean, from the console, you can use pull gcloud pull command. Okay, here if you see, this is the command that we will use to pull the messages from a subscription, right? So that subscription will be internally linked to a topic. So you're not directly communicating to the topic, you're communicating through a subscription. Okay, so EMP subscription. Okay, I'm just pulling the messages from that EMP subscription. Now here I need to push messages, right? So I have created the topic, I have created the subscription. Subscription is for consuming. Remember, subscription is for consuming. You don't need a subscription for pushing the messages, or for a producer. It doesn't require. Okay, now assume this console is my producer, this console is my consumer. Okay, so I'm just starting my consumer. Okay, and I'm just pushing my message to my topic. So my topic is EMP. Okay, and the message that I am pushing is okay. So this is the message I'm pushing. Okay, so when I push it, so the message got pushed. So here if you see, I'm just pushing it again, so it got timeout. See here, immediately your message got received by your consumer. Guys, are you following me? Anybody have any questions? Are you able to understand how we are actually, though it's a console, you just try to understand, the functionality first. Okay, I'll show you the programmatic way. Okay, but remember here, this is your producer console and this is your consumer console. And see, as and when you push the message, how it is coming to your consumer. It is very fast, right? It's not even Okay. So I'm just starting my consumer. I'm just pushing it. See. No, I think I pushed again. Or... Yeah. See. So this is how actually you will experience the streaming speed, guys. Okay. So this is your consumer and this is your producer. So as and when it receives the message, immediately your consumer is picking up. Correct. So that's the beauty of your streaming applications. Okay. And remember, implementing a batch application or implementing a batch data engineering pipeline versus implementing a streaming pipeline or data pipeline. So streaming pipeline is more costly. Be very, very clear. Okay. So if the production demands such kind of streaming data, then only they will go for streaming applications. Okay. If they are okay with the batch intervals, if they are okay with the normal dashboarding or normal reporting, and if they are not really required real-time data for their machine learning or data science, majority of the times machine learning and data science models will run on the historical data only. But if there are any such kind of use cases, just now we have seen a real-time use case, right? So if there are any kind of a production critical applications which demands a streaming data pipeline, then in that case, we have to go and programmatically develop such kind of applications. We have to go and programmatically develop such kind of applications. So here, if you see, you can try this kind of producer and consumer application to in your GCP platform. Okay, in your GCP platform. See here, it's a very simple code, guys. It is not a rocket science as such. So to connect with your GCP platform, you need a ADC file, and we know how to generate that ADC file. And we need to create a credentials object, and you need a topic ID and then publisher and then a topic path. That's it. Publish. That's it. So publisher.publish method you can call and push the message to the topic. That's it. Similarly, you have a consumer which will actually consume the messages using a subscriber. Programmatically also it is very simple. I think I'll upload these two code snippets in the Git repository. I request you to go and tweak these parameters and then try the code in your Vertex AI notebooks. Okay, so that you will understand how to implement them programmatically. Okay, so now let us quickly understand our cloud functions, right? So yesterday we have seen a bucket based trigger. So we have created a cloud function to trigger based on the event from the bucket, right? So now if you see, if you create a cloud function, let us say pub sub trigger. Okay. Oh, in the triggers, if you see, you have pub sub. Okay. And if you see, you can give the topic name. I have EMP. Okay. And then in the next, right? So when you select your Python code or Python kernel, you will see your message, right? Message of data, right? So let's create it and let's push a message. I'm just deploying it. Okay. So now understand the integration, guys. This is very important. The reason why I am telling these many services in real time, the integration matters. How you are integrating PubSub with the cloud functions. Okay. How you are integrating PubSub with the workflow. That is important. Okay. So in data pipeline, typical data pipeline, we will be enabling triggers, right? So we'll develop processing jobs in Dataproc. We'll store data in BigQuery. We do raw data. We load raw data to GCS. These all things we know. But in real time, you need to automate things, right? You need to automate things. Once you develop pipeline, once you deploy pipeline, you are not you don't develop a pipeline for your lifetime, right? You develop and deploy and leave the project and pick another project. That's how real time works, right? So in that kind of environment, it is not required for you to continuously develop that application with manual things, right? So you need to know what are all things that are required to automate your flow, right? So likewise, if you see, we have created a topic, we have created a cloud function with a pub sub trigger, right? So in the logs, if we go, we don't have anything. Okay, so now I'm just trying to push my message, because I have my console producer anyway, and I'm just trying to push my message here. So this is my message. Okay, so I'm just pushing, and just we can go and check whether we have received our message or not. Okay, so we can see our message got received. See, so this is a one way of triggering your cloud function, guys. Okay, similarly you can trigger workflow also with pub/sub message. Okay, so in real time, how we will use these triggers, right? So I will explain a use case with pub/sub trigger. That is currently we are doing that in my project itself. So I have implemented this idea. So let me give you a real-time use case. So here, if you see, now I have my source, okay, and I have implemented I have implemented a data pipeline, okay. And I have loaded data. I mean, it's an incremental pipeline. I'm loading data to my BigQuery every day. All my BigQuery tables are getting loaded with the latest data, and the data frequency or data delay is 12 hours. That means if I go into my BigQuery tables, I can see previous 12 hours. I can see 12 hours delay in my BigQuery table. Okay, that is okay for me. Okay, so because my pipeline is running with 12 hours delay. Okay, so because my reporting doesn't require real-time data, so I have scheduled my pipeline daily twice. So every day it will run and it will trigger load for the previous 12 hours data. Okay, so fine. So now let us see, as and when the BigQuery tables got loaded, your data pipeline also should trigger a machine learning model. Okay, now now our data scientist has developed a machine learning model. Okay, a machine learning model. So this or data science model. Okay, what this model will do, this model will run on this BigQuery data, BigQuery table data every day, and it will predict the next failure. For example, in my case, it's a manufacturing data. So in the manufacturing floor, we'll be having multiple steps, right? So daily we'll be getting data from the machineries, and then it will load the data to BigQuery. Once the processing is completed, once the loading to BigQuery is completed, our data pipeline, what it is doing, so it is pushing a message to a pub/sub. Okay, it is pushing a message to pub/sub, and once it got pushed, then immediately the model will trigger. Okay, immediately the model will trigger. So it's a pub/sub trigger, right? So your data science model uh, is a kind of initiating with the cloud function, and inside the cloud function they are triggering their job. It's a Vertex AI job only, Vertex AI notebook job. So they will deploy their job in the Vertex AI notebook. So with the automated process, they will deploy. So now here, what is happening? our data pipeline is completed. Now immediately what we are doing, we are actually pushing a message to pub sub topic, and from the pub sub topic, immediately automatically your cloud function will trigger, right? And it will take the message, hey, for this table the load got completed, you start the model for the table. So a machine learning model will run, and it will indicate the results in the dashboard. So there will be a front end UI, and in the UI what will happen, so for this machine, uh, failure predicted. Okay, now the test engineers who are operating with the machines, right? So what they will do, they will log into this dashboard, and they will check which machines are going to failure, right? Or which results are accurate, which machine is giving accurate results, and which machine is going for the service in the future. So all this data they can see in the dashboard itself, so that it will improvise their testing activity on a high level note. Because of this, what it is going to improve, for example, I don't know how this machine is performing, I am doing the testing, it has given the wrong results, and I have taken that same product and tested in another machine, it has given the right results. So that means, where is the problem? The machine is the problem, right? So if we create a dashboard for the test engineers to select the good machine, right, or to predict whether this machine is going to give you proper results or not, then in that case the test engineer will take right decision when he is testing. Because of that reason, he don't go for the retests, right? So that is the core intention of this application, and this is how we are integrating our data pipeline with the machine learning pipeline using a pub sub trigger. And internal to the data pipeline also, you may use pub sub trigger between the services. Let us say you want to trigger a cloud function, and then after the cloud function you want to push a message to the pub sub and trigger another application, something like that. You can still use this pub sub between your data pipeline also. Okay, guys, are you clear? I mean, are we good with a pub sub introduction? I mean, this is, I'm just giving you introduction, just you need to know how to integrate things, so you can deep dive and know more about pub sub, how it works. But I want to explain you the real time use cases so that you will adopt fast. Okay, so any questions, guys? Any questions in today's pub sub service? Are we clear?
Yes, I'm clear.
Yeah.
Okay, fine. So that's all I have for today, guys. Okay, so thank you so much for joining. We'll connect back on Sunday. Okay, Sunday the session will start from 7 to 9. I mean, so it will go till 9. Okay, the reason being, we have to see workflow in the first session, and we'll take 15 minutes break, and then we will see real-time project execution. I mean, the implementation. I'll just give you the architecture, and you have to do a POC on it. Okay, so that is our next step. So Sunday is the conclusion session. Okay. Yesterday, I have posted the payment related information in the group. So please go ahead and check if anybody is pending with the payments. So please proceed with your payments. Okay. Yeah, that's all I have. Let's connect back on Sunday, and hope in Sunday's session you will get the complete picture of Google Cloud data engineering pipeline. Okay. Till now we have seen bits and pieces. Okay, cloud function, we have seen pub sub, we have seen dataproc, GCS, BigQuery, stored procs. We have seen bits and pieces. So now in on Sunday we will see a workflow orchestration where actually we'll connect all these services. Okay, where we'll connect all these services, and we will schedule that pipeline, or will trigger that pipeline, right, on a pub sub node, or a cloud scheduler node, or a cloud function, however it is possible. I'll show you. Okay, so that's the coming class, guys. So it's a very important 2 hour session, so I request everybody to join and understand how actually the GCP data pipeline will work. Okay. Yep. Thank you so much for joining once again on Sunday. Yeah.
Thank you,
Thanks,
sir.
sir.